Hey everybody! The purpose of this video is to help us through problem 2.13.22 from Collaborative Statistics. It involves two, it looks like, supervisors at a shopping mall, and they both want to estimate how far away from the mall shoppers live. And they each took a sample of 100, and these are the summary statistics of what they got. They both got an average of 6 miles. But one survey has a sample standard deviation of 4, plus or minus 4, and one is a plus or minus 7. So if you're looking at like a definition or using the definition, on average, the shoppers live about 4 miles up or down from 6. This is via Javier's study, and Arcia's study. They live plus or minus 7 miles away from 6, which seems kind of weird because 7 miles down from 6 would be negative 1 miles, which would mean they'd live like inside the bathroom at the mall. We'll come back to that. Part A, it says, how can you determine which survey is correct? The 7 is suspect. It's a tricky question. The 7 is a suspect value. And it's hard to answer part A until you look at the graphs down in part C. So let's come back to part A. Part B says, explain what the difference in the results of the surveys implies about the data. Well, there were two takeaways about standard deviation I wanted you to make. The first was the definition. Well, the rough definition of it's the average distance away from average. Okay, now that we can get more from that too, but that's kind of a rough idea. The second one is the bigger a sample standard deviation is, the more variable the data. That means Arcia's data was more variable than Javier's. That's all we can take away, assuming it was done correctly, which it looks like it might not have been, but we'll come back to that as well. Okay, so far? Okay, so far. So basically, Arcia's data was more variable. There was more dispersion in her data than there was in Javier's. Okay, part C says, here are the two distributions, one for one and one for the other. Which one is Arcia's? Now remember, Arcia is this over here, the 6 mile average with the 7 mile standard deviation. Okay, which one has to be hers? Well, you have to take some liberties with how they scale things. All that is in the textbook is there's a 6 in the middle of the graph. Now I'm assuming that means 6 miles. I think that's pretty fair. It's the balance point of both these graphs. And I'm assuming this guy over here is 0. So that means this represents the data between 0 and 2, 2 and 4, 4 and 6, 6 and 8, or maybe this right in the middle is 6, that would make this 4, that would make this 2. I mean, it doesn't really matter, you're getting close at that point. Basically though, what this tells me is no matter how I look at this, if I call this 6 and I call this 8, this point out here can be no more than 9. Can't be any more than 9. I mean, it might be 8. If it's 0, 2, 2, 4, 4, 6, 6, 8, it might be 8. If I call 6 the middle, that means 4, 2, 8, that would put this at 9, but it can't be any more than that if they scaled it correctly. Likewise, over here, same thing. 2, 4, 6, 8, 10, or 6, 8, 10, 11. This guy is no more than 11. Now what does this tell me? This tells me that when I look, let's look at number 2 here for a second. When I look at number 2, the maximum distance that a person who was asked by either of these two supervisors lives away from the mall is 11 miles. 11 miles is 5 miles above 6. That means the maximum possible value of the standard deviation is going to be 5 if they're here, or 6 if they basically live right next door to the mall. So in other words, the maximum possible value is going to be 6. 5 on this side, 6 on this side, same as over here. 3 on this side, or 6 on this side. So basically, you can't respond, if you will, more than 6 miles away from the average. I don't see how you can possibly get a sample standard deviation of 7 if your maximum data value is 6. It's kind of like saying, well, I got hundreds on all my exams, but I have 105 in the course for an average. You can't average higher than your highest exam score. Your average has to be between them somewhere. So I think there's some suspectness in this 7. So that's the answer to part A. As far as the answer to part B, part C, I'm still going to go with the fact that Ursia's data has a wider standard deviation than Javier. So since it's a wider, that means Ursia's data has to be more varied than Javier's. That data is more varied. It's more spread out. This data is more clustered around the average. It's actually kind of following a bell-shaped curve. That means this bad boy has to have the smaller standard deviation, which means this bad boy is going to be Javier's data. And Ursia has to be that data over there. She, I'm guessing, miscalculated the standard deviation somehow. You can approximate what the standard deviations are if you throw them into a calculator. It's kind of hard because you have to kind of ballpark the values. But with this one, it's not that bad. Assuming that they did 100 data points and did them correctly, each of these frequencies would be 20. So you can run one of our stats with L2 being 20, 20, 20, 20, 20. Sorry, sound like a Ramones song. And then the data points here, you would either put 2, 4, 6, 8, 10, or 1, 3, 5, 7, 9. Run it that way, and you'll see what the standard deviation works out being. It's far less than 7. So, hope that helped.